Hello everyone. My this is my topic number 5 is second order reaction and nth order reaction. So previously I have uploaded two videos, two lectures from chemical kinetics. One was the introductory part and how we are determining rate law and rate equations. So that was there, and second one was zero order and first order reaction. So I thought if you know the zero order and first order reaction and the introduction part, so it will be incomplete if I don't upload the next part. Okay, so your knowledge will be incomplete. So that's why I am again here with chemical kinetics topic. So let's start with that. And one more thing that again this lecture will be not a descriptive type. I will not focus on the how the formulas actually are the calculating and other things. So I will not go to the derivation part. So I will show you how the formulas are coming, and what will be the formula and what to remember. That I will tell you, and after that we will go towards the question session. So easy to moderate and hard questions are there. So hard questions are also easy if you know the real trick, which trick are need to uh, actually use. Okay, so that is there. So I will teach you that. And so let's start with this new topic with a new energy. Okay, new energy, no, with a high energy. Okay, so I hope you will enjoy this session and this will be helpful for you all, I am assuring you. So now second order reaction. So you know, right? Zero order, first order. So you know that what is order of reaction. So that kind of thing you will know. So let's start then. So if a second order reaction is like A is giving P, then the rate can be, as it is a second order reaction, the rate can be written like this one. A rate equal to K A to the power 2, where 2 is representing the second order reaction. This is order, right? So you can be asked that here 2 is not here, but it is written the second order reaction, right? Many of you or some of you have the question that it should be here, 2 should be here. How can I here put the 2 in this power, right? But I am not claiming what I have taught you previously, that if for an elementary reaction only, the order can be equal to molecularity. But I am not saying here that it is an elementary step reaction. It can be complex reaction. So I can write rate like this way and the reaction like this way. Okay. Because order is a experimentally determined quantity. Clear? So now if we plot again, this is concentration. If we plot reaction rate versus concentration for a second order reaction, it will be like y equal to x square. Okay, so it will be like this. Okay, so unit of rate constant. You know these things, right? But I want to know that you have read that carefully or not. So for rate constant, is it depending on order or not? It is, right? So that's why I am again saying rate constant for zero order I have shown to you, for first order I have shown to you, and then again for second order. For nth order reaction also I have shown the rate constant to you, so that you can calculate the rate constant you need for any reaction, any order reaction. Okay. So here, so this is the formula, right? Mole liter inverse to the power 1 by, minus n time inverse. N is the order of the reaction. So here we are putting n equal to 2, and then this will be there. So overall the unit of rate constant will be mole inverse liter time inverse. Okay. So now integrated rate law. So we are now assuming that these A molecules are only here, but one other representation of second order reaction is also there. with A plus B giving P. I will come to that part, but before that, let's read only this one. So for easy your to easy understanding, let's put here too, so that you can relate it, right, like that only A molecules, various A molecules are there. Okay, so that's the thing, but if you don't put it here, that will be also fine. So now for forget about this one, we will come to it again in the latest slide. So now the part is at t equal to 0 second, the initial concentration is A0 and the product is 0. At t equal to t, At will be the concentration of the reactant, which is A0 minus X, and P will be X. So it is the same thing written here, if you see, and then we can write rate equals to, we know, minus dA by dt, dp equal to dp by dt equal to k At to the power 2. Okay, so we can write here minus dA by dt equal to k a to the power 2 or At also you can write At to the power 2. Okay, so now from this equation, this is coming after integration. Okay, so I can show you if it, you thought, if you think that it is difficult, so ma'am is not saying the whole thing. So for that purpose, I am just simplified this form, dA by At square equal to K into dt, right? So you are integrating this one 0 to t and A0 to At. So what will be integration of this one? This square, right? 1 by x square dx. What will be the integration? Minus 1 by a, right? So if we put limit, then this equation will come. Hope you understood this. Okay. So now coming to the graphical representation. Okay. So graphical representation of this kind of second order reaction. This kind. Okay. This is the first kind of second order reaction. So if we plot 1 by At versus time. Okay. Time is here. Then what will be the graph look like? This is very important. Sometimes only graphs are they will tell you this versus this is plotted, and the graph is a straight line, like that way. So you have to find out that which order reaction this is. Sometimes this can be the question. So in the question part, I will come to that also. So here, if we compare this with y equal to mx plus c, then it will be justified, right? So this is y mx plus c. So c is the intercept and m is the slope. Here m will be, or slope will be, equal to k, and intercept will be equal to 1 by a0. Okay, so if any question is asking you that it is a second order reaction and slope is given, intercept is given, and you are asked to calculate the slope, rate constant value or initial concentration of reactant value. So see how easy this is. With the slope and intercept value, we can easily know the value of these two. Okay, so this you have to keep in mind. So after that, half life, we know when t equal to t half, At will be A0, right? So if we put this one, what value we can get? Let's not let's not see these. Okay, you calculate it first. A0 by 2 equal to kt half plus 1 by A0. Okay, so k into t half will be 2 will be here, so 2 by A0 minus 1 by A0, which will be 1 by A0, right? Will be 1 by A0. So t half will be 1 by k into A0. See, same thing, right? Same thing. So yes, we have calculated this. Okay, I hope you understood. Okay, clear. Next, the integrated rate law for A plus B giving P. This is another type of second order reaction. So at T equal to 0, let's say initial concentration of A is A, small a, and B is small b. And at initial P is 0, obviously at T equal to T second, A will be A minus X, B will be B minus X, and the product will be X. Clear? So now we know that rate is minus dA by dt minus dB by dt equal to dP dt. Okay, and we can write the rate law here like this way: K into AT BT. Okay, we can also put the value of AT and BT here. Then the formula will look like this. Okay. Next, so minus dA minus X by dt equal to this one. Then, so this will be 0, right? If we solve it, minus dA by dt. dA is a constant value, so it will be 0. 0. So this will be there only, and k into a minus x and b minus x. Okay, so if we integrate this one, we will get this one. Okay, I am not going to the derivation part because it will be lengthy. So this will be here. So it will be going here actually. So it will be dx by a minus x and b minus x, and again equal to k dt. Integration will be here and here. Okay, so after rearranging and after some derivation, so this will be the actual integrated rate law for this kind of reaction. So it will be also helpful. So it is good to remember this one also, because sometimes questions are there from this kind of this equation. Okay, so it is better to remember this one, I will say. And for the rest of the part, we have the nth order reaction. So if let's say we want to know the third, for the integrated rate law for the third order reaction, and then fourth order, fifth order, so the derivation part will be also difficult, and we are we can forget things, right? So if many, because zero order, first order, second order, if you are remembering, then again third order, fourth order will be difficult. So some generalized formula should be there to remember things in a better way. So for this, nth order reaction is there. So it is very important thing is there. Please look into this. It will be valid for n equal to or greater than 2. So in n equal to 2, 3, 4, 5, 6, etc. Okay, will be valid for any kind of this after greater than 2 or 2 values. Okay, clear? So second order reaction which we can derive from this formula also. Okay, so here, so if any nth order reaction is looking like this one, and rate will be then Ka to the power n, obviously the order is n. So integrated rate law will be Kt 1 by n minus 1, 1 by A2 to the power n minus 1 minus 1 by A0 to the power n minus 1. Okay, so we have just now we have shown you the integrated rate law after many calculations and integration, okay, which was for rate equal to K A to the power 2. We have shown to you, right? So let's try to calculate it in this manner. Okay, then it will be Kt equal to n equal to 2, we have to put 2 minus 1, okay, third bracket, 1 by 80 to the power 2 minus 1 minus 1 by A0 to the power 2 minus 1. Clear? Okay, so what will be the equation? 1 by 1, we should not write it, right? 1 by 1 is obviously 1. So what will be here? 1 by 80 to the power n, sorry, not n, only 80, because 2 minus 1 is 1 minus 1 by a. So equal to this one, Kt, right? So this was the equation of second order reaction, integrated rate law for second order reaction. Remember? Just now we have actually read about it. I have shown to you. The graph also we have plotted with 1 by 80 versus time, right? Okay, if you forget about it, let's take a look. This one, right? The same. Okay, so only if you only remember this nth order formula, you can calculate the n equal to 2, also n equal to 3, right? So for n equal to 3, you have to just put n equal to 3 here. Kt equals to 1 by n equal to 3 means here it will be 2, and it will be 1 by 80 to the power 3 minus 2 square minus 1 by A0 to the power square. Simple. So we don't have to go towards the derivation part and the various integrations and all. So we can calculate it by remembering this one. Okay. Please see it carefully. Okay. Clear? Please see it carefully and try to remember this. Not try, please remember this one. So it will be very much helpful for any kind of question. Next, the half-life. We know we have calculated half-life for zero order, first order, second order, right? But if you are asked that for a fifth order reaction, half-life is this, and everything, anything like this can be asked, right? But we know only to second order. Till second order reaction, the half-life is known, right? But we can show from here, we can calculate here the half-life for nth order reaction, so that we can put again n equal to 2, 3, 4, and we can calculate the half-life of any reaction. Okay, let's see. This will be the T half equation. 2 to the power n minus 1, here minus is here, but it will be not here, it will be here. Okay, 2 to the power n minus 1 minus 1, below here it is n minus 1 into k into 1 by a0 to the power n minus 1. Okay, so sometimes in the questions this first part is not very important. This first part is not very important because it will be cut out if you are given two t-half values and this a0 value are different. So that time, so only the whole formula is important, I know, but this is must, you should remember 1 by a0 to the power n minus 1. So if you forget about some terms here also, but you can solve many questions with this knowledge only, that t half is inversely proportional to a0 to the power n minus 1, or it is proportional to a0 to the power 1 minus n. Same thing, right? We have to remember this one. So now if we calculate n equal to 2, we have just uh, shown you for n equal to 2, right? So if n equal to 2, we put here t half will be equal to 2 to the power 2 minus 1 minus 1. Clear? Okay. Below 2 minus 1 k into 1 by a0 to the power 2 minus 1. So here, okay, I am again simplifying this. 2 to the power 1 minus 1 by 1 into k into 1 by a0 to the power 1. Okay. So what will be the t half value for second order reaction? Will be this. Is it different than previous one which we have calculated? Let's see. A0 into k, right? So the same thing we have calculated with nth order, or yes, the t half value for nth order, from the t half value for nth order reaction, right? So it is easy now. So from so you have to remember, for the whole formula you have to remember the zero order and first order, and rest actually you can solve with nth order reaction if you remember. So you have to remember three things. Okay. I'm not solving n equal to 3 and 4. You can solve it. Okay. So it is, I am leaving for you guys. So the formulas you have to remember is for integrated rate law for first order reaction, which is Kt equal to ln A by A minus x. This is first order. First order. For second order, it was, sorry, for zero order, it was x equal to Kt, or A0 A0 minus AT equal to Kt. Okay. These two you have to remember. These two. This is for first order. First order. This is for zero order. Zero order. Okay. These two you have to remember, and then you have to remember this one for nth order reaction, and you have to remember the T half for the nth order reaction. Okay. Clear? For the other T half, actually you can put the value AT will be A0 by 2, and you can remember it also, because for the first order reaction T half value is very important, because it is frequently asked in 2 by K, because it is not actually depending on the concentration of initial concentration of reactant. Okay. So I will come to this part, that part. And okay, what are the things you have to remember? This four is there, this and this one and this one, and what will be next? So I have previously told you, na, the second kind of the second order reaction, this one you can remember actually. Okay, so let's come to the next topic, which is, after that we will go to the question session. So how to determine the order of a reaction? So previously, so in the introductory part, I have shown you some questions to determine the order. So one was the from the unit of the rate constant, right? As unit of rate constant has one order part. Okay, so if the unit of rate constant is given in the question, you can easily know about the order of the reaction, right? And another thing also we have done, various values are actually given. From that, yes, some experiments I have shown you. Experiment 1 is a concentration of, let's say, A is doubled or B is constant, then rate will be doubled or something like that. So from that also you can calculate the order. Okay, and here some important methods are given actually to calculate the order of the reaction. So what it is, what are these? So one is half-life method. So what is that actually? So we know, we have just read that T half is equal to this one. Okay, so we can say that T half is proportional. It will be proportional sign, not equal to, proportional to 1 by A0 to the power n minus 1 and A0 to the power 1 minus n. Okay, so if in any question, okay, if in any question they have told you that T half, when the initial concentration is, let's say, A1, then T half value is, let's say, 10 seconds. And if this is A2, then T half concentration is, let's say, 20 seconds. Okay, so the questions, it needs actually order of the equation. Okay, so what you can do, simply forget about this whole formula. Okay, so you can T half 2 by T half 1 will be, sorry, A1. It will be inversely proportional, right? So A1 will be here, A1 by A2 here, in minus 1, in minus 1. So overall we can use only 1 in minus 1, like this one, right? So if we know this and this value, if you know this value and this value, and also one of the concentrations are actually given, then uh, you can sorry, two concentrations are also given, then you can actually determine the order of the reaction. Okay, so that's how you can take log also both side, that will be simpler, simplified. So log, let's say, T half 2 by T half 1 equal to, so after taking log, it will be coming, it will come to this side, and log A1 by A2. Okay, so like that you can easily solve this kind of question. Now the graphical method. So graphs actually we have read in many portions for order of reaction, like zero order reaction, first order, second order. So that graphs actually can tell you what is the order of reaction. Okay. So I have told you when I was teaching these reactions to you, or these graphical graphs I have shown to you. At that time I have told you this part, right? This is for second order reaction. This is for zero order reaction, zero. This is for first order reaction. Okay, this second. So if in the question it is given that 1 by AT versus T is plotted, okay, uh, and the slope is this, and it is giving a straight line equation, okay, so then you can have the idea that if we plot this versus this will be a straight line plot with intercept. Don't forget about that, with intercept, positive and positive slope. Slope is positive. So here straight line, positive slope with intercept. Okay, like this, right? So here it is, and then for zero order reaction, if we plot, okay, here from here AT will be A0 minus AT, right? So if we plot here 1 by A2 versus 5. If in the question it is saying that they are plotting AT versus T and they are getting a negative slope, this one, right? Then that will be the zero order reaction. Okay. Then for this one, if they are saying that they are plotting like log or ln, ln a0 by a0 minus x versus t, they are plotting and they are getting a straight line without any intercept, like it is from origin. So then it will be first order. So the question can be differently asked, but like this way, which I am telling you. Okay. So you have to have idea about this kind of equations, integrated rate law, and the graphs are which are made from this. Okay, which has negative slope, positive slope, intercept is there or not. This you have to remember, or you have to keep in mind. If you don't remember, that is fine, but you have to quickly solve this one. Like for first order, which will be, what will be the graph, what will be its slope. Okay. Then the integrated rate law method. So from integrated rate law method, actually, so if you know these equations, these three, let's say these three equations, so various data are given that at t and the concentration of, let's say, reactant, various data are given here, and also the rates also you can they can give. But if they are only T and A values are given, various T and A values, from that it is a hit and trial method. So from that values you have to put it in all the equations and see it is matching with left right hand, the left hand right hand is matching with the hand side or not. Okay, because if this is the given, okay, a zero value at t equal to 0, let's say something, so this left hand side value, this one should be matched with right hand side value, then it is second order reaction. But it is not, then come to the zero order first order reaction, then come to the zero. So actually this is not the process. You have to first start with easy one. You have to start with zero, then first order, then second order. Okay, zero, first order, and then second order. Okay, by putting value we can have the idea. It will be actually a lengthy type of method, so try to avoid this kind of questions, because much time will be gone for this kind of questions. Okay, so that's all. So coming, I am going to the question part. So first question is here. So this is actually informative. So that's why I am putting this in my slide. So what type of reaction this is? What is going on here? We know, right? So by seeing a equation or by by seeing a reaction, we can't tell what is the order of reaction. But why it is given then? There can be some reason, right? There should be some reason, because we can only determine by experimentally, and some experiment or some experimental method I have shown to you just now. But how, why then these kind of questions are asked? Okay, first see what is this. This is ester. COO bond is there, COOR. Okay, this is ester, this is water, and giving acid and alcohol. So it is a ester hydrolysis, and H plus is given. Acidic medium, in acidic medium, ester hydrolysis is going on. What type of reaction this is? Okay, let's say it is given that it is a elementary step reaction. So no other steps are here, right? So we have to consider it as a elementary step reaction, one step reaction. Okay. Oh, you will say then it is easy. For elementary step reaction, we know that molecularity is equal to order. So here 1 and 2 molecules are there. So it should be second order. D will be answer. But here this is not the answer, because so you are saying that, sorry, rate will be, R will be K into CH3 COO CH3 into water. Okay, you are saying like that. So it will be second order, first order with respect to ester, and first order with respect to water. Okay, you are saying that, right? But why it is not happening here? Because this is when sometimes uh, we know here water is a solvent, right? So whenever that is the case, that the solvent concentration or the amount of solvent or any reactant concentration is very high with respect to the other reactant, that time we can say, or we can take that reactant as constant. This one, as it is a solvent. So in that medium only reaction is happening. So if this we know that rate, what is rate actually? Rate is the decrease in the concentration of reactant. If we write minus dA by dt, okay, that will be rate. But in this case, the H2O by dt with respect to H2O, the rate will be, we can't determine, because this will be zero almost, because H2 is in huge amount, so that we can't find the change of its concentration. Okay, so we have to take this H2O concentration as constant. Then K H2O into ester will be here. This will be again a constant, and it is constant obviously. So K dash ester. Now this is the rate. This is the rate. So we know that whenever in any reaction, rate equal to K A to the power something, it will be order. So here order is 1, n equal to 1. So it will be first order. Okay, first order reaction. One second order reaction is actually showing the properties of first order reaction. Okay, so that is the case here. But in this case, it is actually called the pseudo first order. Pseudo. Okay, This is not a real first order reaction. This is second order, but it is acting like the first order. So it is pseudo first order reaction. Please remember this. The example is ester hydrolysis. Okay? Because here one reactant, this is H2O, which is taken as solvent and it is not changing with time. Because it has a huge concentration, the small changes can be negligible. Okay? Next. Okay. If the rate laws are expressed in concentration unit, mole decimeter to the power -3. Concentration mole per liter. Liter is actually, this is actually liter. Okay. We are not changing here decimeter to liter because here it is given and we have to we have to choose an answer in with respect to decimeter only. So here the unit of third order reaction rate constant we should actually calculate. Unit of third order reaction rate constant. Okay. Okay. So for rate constant, we know the general formula. Mole per liter to the power 1 minus n. Yes, and t to the power -1. This is the general formula. And here third order reaction. It is saying third order reaction. So only we will put n equal to 3 mole per liter and we are putting n equal to 3. It will be -2 to the power t to the power -1. So here, sorry, again we have put liter here. So we will go towards decimeter. Okay, mole decimeter cube. This is liter. Okay, decimeter cube. Mole per liter. This is right. -1. -1. So it will be -3 and this -2 and T I am saying here, but we have to put second here, second inverse. Okay, then it will be mole to the power -2, decimeter to the power -6 and second to the power -1. This will be the answer. 3 into 2 will be 6 and it will be +6, not minus, because minus minus is there, so +6. So only write 6. Clear? So this will be the answer. Decimeter 6, mole to the power -1 second. Okay. Right answer is B. Clear? Next. If the unit of rate constant of a reaction is liter to the power q mole to the power -3 and second inverse, the order of the reaction is. The same kind of questions, just the reverse thing is given. Okay. So the unit of rate constant actually given here. So we know that mole liter inverse to the power 1 minus n and time or second, not time, second to the power -1. Okay, so we have to calculate n here, n value, and it is given that the equal to, it will be, okay, mole -3 liter cube second inverse. So we have to solve this, right? So mole to the power 1 minus n liter to the power -1 was there, n -1. Clear? Okay. and second inverse equal to same. Okay, same. Okay, mole per liter, 1 minus n and n minus 1. Okay, so if we compare this mole to the power, the power of mole, if we compare this one, this two, what we get? 1 minus n will be equal to minus 3, right? So n will be, if we go to this side, n, if we take in this side, 3 plus 1, I think. Yes, so it will be 4. Clear? So the order, so the order of reaction will be 4 here. This will be the answer. Okay, this is a previous year question of NET June 2018. Next. So the half-life of the hydrolysis of an ester varies with initial concentration of the reactant E0 as follows. Okay, it is a question from GATE. So we have to actually calculate the order of the reaction. Yes, it is not given here, but the order of the reaction, order. We have to find out the order. Okay. So how can we solve this? Here nothing is given. Yeah, we know that. Okay, let's not talk about this. So we are just calculating here. Okay. How? We know that T half is proportional to 1 by A0 to the power n minus 1, where n is the order. Okay. So E0 value, various E0 value is given, and we are seeing that this is changing actually T half. So if it is first order reaction, so first order reaction, for the case of first order reaction, it is not depending on, it will be not changing on the A0 value. So it is not first order. This option we can cut it right now. Okay. So let's coming to these values. So we know only this one. So how can we solve this? So let's take T half value from this one, 240 equal to, let's say, K into 1 by 5. 5 is there, right? 5. 5 to the power n minus 1. This is equation number 1. And again, from the second value here, okay, if we take this, 300 will be K into, again, 1 by 4 to the power n minus 1, right? This is 2. Let's try to divide this one, like 2 by 1. Let's try to this. Let's check what will happen. 300 by 240. You're following, right? And K will be cut down, and this will be, so 300 is there, so here below is 4 to the power. Okay. So, and here is 5. So it will be 5 by 4 to the power n minus 1. Please try to understand here. Be careful, okay? Now, will be equal to, this will be cut down, and okay, let's cut down with 2, 12 and 15. So 15 by 12. Oh, we can again cut it down, sorry. 3, 5 and 3, 4. Okay. So 5 by 4 we got, right? And here 5 by 4 is given. So to the power actually it is 1. I was about to write in -1, but here it is 1, right? We get that 1. So comparing this one with this one, this and this, what we are getting? n-1 will be 1. So n will be equal to 2, right? So we got the answer. Here n will be equal to 2. So how we get it? I previously told you in the how can we determine the order of a reaction. In that part, I have told you that if we know the various TF values and various initial concentration of reactant, we can actually solve or we can determine the order of reaction. So here it is an example. Okay. So just I have put these two values in this. So this is important here. See, the whole actually the whole equation of the T half or formula, there is no need of that here. Only the proportional part is very important, that we can, the other part is constant, right? We can remove it or it will be cut out. Okay. So next, the concentration of a reactant R varies with time for two different reactions are as shown in the following plots. Okay, two plots are given here. So what will be the order of reaction? This is a question from CSIR NET December 2015. So first equation you can see here, R is the reactant concentration. R is the reactant concentration versus time, and it has, so just write down the feature of the plot so that we can have the idea about which order reaction can give a integrated rate law equation like this. Okay, so just for one we can write negative slope, and of course it is a straight line with a intercept present, right? Only these these three we can say in this one. Okay, first try to solve only this graph, then we will go to this one, next one. So if you remember, for the first order reaction there was a log value, right? But here no log values are there, only AT or R. Here R is given. Okay, so if we think about a zero order reaction, what it was, the integrated rate law is equal to KT, or A0 minus AT equal to KT. It is there, right? And so AT will be equal to A0 minus KT, and here AT is like R here. So it will be R minus R equal to R0 minus K into T. So it has a, if we plot R versus T like this one, it has a negative slope. Slope will be minus K. Slope will be minus K. And intercept will be C, intercept will be R0. Okay, let's not talk about this, but if you follow that, it has a negative slope and with a intercept and straight line equation. So it is a zero order reaction. It is zero. So this is, I am cutting out, this will be, so two options are gone because first one will be zero order, and so for the second one it is given 1 and 2. We know that for the first order reaction the log value should be there, but here only 1 by R is given, no log. Okay, so from that only we can say that it will be, this one will be correct answer. But I am solving here for your understanding purpose, so that you will not be confused. Okay, so the zero order reaction we have seen. So the only left reaction, which reactions are left? Only second order and nth order. So let's say the second order reaction. Okay, so what it was actually for second order reaction, the rate equation Kt equal to 1 by At minus 1 by A0. If you forget it, don't worry, just remember the nth order reaction, the whole formula, and put 2 there. Okay, some things you have to remember, right? So if we put R here, then the reaction will be reformed like Kt equal to 1 by R minus 1 by R0. Okay, so 1 by R will be equal to Kt plus 1 by R0. So if we plot 1 by R versus T, see 1 by R versus T, this will be like y equal to mx plus c, y equal to mx plus c. If we can compare, so it has a positive slope, slope is positive, slope positive, a straight line, and the intercept value is 1 by R0. Here intercept value is not given, so let's not talk about this, but it has an intercept and it has a slope of positive slope. Okay, so this will be second order reaction. Clear? So C will be the answer. Okay, so you have to first catch that from which equation we have read about only a few, right? So from which integrated rate law equation we can get this kind of graph. Okay, you have to just, a clear knowledge is important here. Okay, very important, interesting questions these are, right? Okay, let's see this question. This is also has come in CSIR NET December 2017 exam, right? You can see here. So this is also a very important question. So reaction between A and B is carried out for a different initial concentration and corresponding to half-life times are measured. Data is given. So in the data, what is given? So a reaction is happening with A plus B is giving product. Okay. So here A0, the concentration of initial concentration of A is given various concentrations. So B0 also given, and 4 entries are there if you see, and the corresponding T half values for this one is there. But if you follow or if you remember my previous slides, I have only told you about the integrated rate law for this kind of second order reaction. I have shown to you. But what will be the T half for this case? That case, that because we know that T half is by a to the power n minus 1. So you can be confused that only one concentration we can write like that. But for two concentrations, how can we write? This can be your question, right? Okay. But just see, you can be puzzled here that we don't know the equation, so we can't solve it. Right? This will be your feeling right now. But I am telling you how you can easily, by a trick, you can solve the question. Only see the data. Don't worry, don't be afraid. You can solve it, okay? So here for 1 and 2 entry, you can see this is constant. These they are not changing. Okay? But B is changing. They have changed the B. Fine. But if you see, the T half value has not changed. T half value is same. So what is the conclusion from these two? That when we are changing the B concentration, keeping the A concentration constant, that time T half value is not changing. That means that T half value is not depending on the concentration of B0. That is clear from the first two entries. Okay, because here we are differentiating between this B0 value, but T half has not changed. But if you see that when B is constant, the data entry number 3 and 4, when B0 values are keeping, we are keeping constant, and A0 is varied, 10 it was and then 20, that time if you see T half value has changed. So it is depending on A0 value. Clear? Okay. How it is depending, that I will come to that one. But first you have to clearly see that T half value is not depending on B0 concentration. What it can tell you? We know that T half is proportional to A0 to the power n minus 1. So when we put, or if for the first order reaction when n equal to 1, then T half value will not depend upon the concentration of A0, right? So for the first order reaction, that is the case. So we can say the reaction is first order with respect to B. So the reaction rate will depend on the B0 concentration, or B here concentration on 1. Okay, that we can easily conclude from that entry number 1 and 2. Fine, here is it is. Now coming to the second part. So here this is constant and T half value is changing, like it is 20. T half is 20 by 10. So I am dividing 4 by 3. Okay, so I am right now using a shortcut because you know these things. Okay, I have told you many times, so I am just using the shortcuts. So this will be the A to the power. So 20 is there, so A corresponding A value should be here, right? So A value is, sorry, this is A value, right? Oh, okay. I will put here T half values. So for 4, T half value is 30. 30 by 60. And for 30 corresponding A0 value is 20. And here this is 10 to the power n minus 1. Right? Inversely proportional to A0 to the power n minus 1. Like that way. So half, and this will be also 3 to half. So what is the here? We are getting 1 by 2 to the power n minus 1 equal to 1 by 2. Okay. So n minus 1 will be equal to 1 and n will be equal to 2. If we can compare this one and this one. Right? So n will be 2 means rate will be depending on the concentration of A to the power 2. So overall rate equation, rate law will be K is where B. So the rate law will be this one. If you are asked that what will be the order of reaction, then what will be the order of reaction? Will be 2 plus 1, that is 3. Clear? So here if you see that only remembering the basic formulas and the basic idea, you can actually solve various tough questions also. So it is easy, right? What time it will take? Only 2 to 3 minutes. Okay. So try to catch this kind of tricks in many questions. Okay, to solve like various this kind of question mainly, where the table and datas are given, many datas are 6, 7, 8 datas are given, and you are confused that how can I solve you within few minutes, right? So these kind of tricks can be applied to them. So just drag your mind towards this. Okay, so keep learning with me, right? Like that way, so I can help you with some these kind of tricks and tips. And hope you enjoyed this session. And if you have some queries, and if there is some part you want to again you want to know, okay, so you can ask me in the comment section. So thank you so much for listening.